So today we're going to take our lines one step further, and we're going to start talking about how those lines are, well, slanted. The word we're going to be using is slope, and today we're going to learn how to find the slope. We're going to tie a number to how steep a line is, and we're going to find that slope by looking at a picture, a graph, 2 points like the coordinates without the graph, and a table. So let's just start by thinking about slopes like hills or ski slopes or ramps, handicap ramps, or even a staircase has slope to it. And again, it's how steep something is. Oftentimes you can see these signs posted if you're driving through mountains or very hilly terrain. There'll be these signs on the side of the road alerting truck drivers to how steep the road is. So steepness and slope are synonyms. If you take your volume 1 book and please open to page 181, we're going to see the definition of slope. And slope is going to describe steepness of a straight line. It's going to be a ratio, and what a ratio means is basically a fraction that's going to have a numerator and a denominator. When we're talking about slope in math, we want to know how much does your elevation change? How much do you go up? How much does your vertical rise change compared to how much do you go kind of left to right, or what's called a run? So it's a ratio of rise, which is going up, vertical, think of the y-axis, to your horizontal change, which would be your run, that would be like your x-axis. So how much does a line go up? At the same time, we're going to compare it to how much does it go left to right. So the first way we're going to be able to tell slope is we're going to simply look at a picture. So if you were on a ride at an amusement park and it rises 8 feet for every horizontal change of 2 feet, how would you determine the slope? So remember that slope in math is rise over run. So when we look at this picture, you'll notice I drew a picture to kind of go with this. Remember they said rise of 8 feet with a horizontal change of 2 feet. So I made a little picture to kind of the track of the roller coaster. So which number is the rise? The one that looks like the y-axis, that is rising, that is going up. That would be your rise number. And the number that is going left to right horizontally would be your run number. So initially our slope would be 8 over 2. Now look at that as a fraction. Can we reduce it? First of all, some of you might realize right away that 8 is divisible by 2, right? But if we cut these both in half, you'd have 4 over 1. So for every 4 feet that this ride goes up, it will go 1 to the horizontal change in distance, or 4. So if you write it as 4 over 1, perfect. If you write it as 4, that's fine. Don't leave it as 8 over 2. Reduce it, please. So just to kind of recap this idea, slope is rise over run. And I should let you know as we go forward, you'll start seeing that the letter M is the abbreviation for slope in math, not S. M, think of mountain. S is used in other places, basically. So anyway, slope is change in the vertical direction, your rise, over change in the horizontal direction, which is run. So one thing I always say to my students is if we had to get out of the room in a hurry, if there was a fire alarm, you would rise before you run. So remember that the leader is your top number. So rise goes on top, run goes on the bottom. The number one mistake in slope is to reverse that. Just so you see it in the future, sometimes you'll see slope defined with these little triangles, and that is the Greek letter D, delta. And generally in science and math, delta means change. So this delta y over delta x is just another way to write this. It's changing in the y direction, oh, by the way, rise, over change in the x direction, which is run. So basically, here's an example of a treadmill, and we want to calculate the slope. We've got the picture. So we've got 2 numbers here that we're comparing. So what you just have to decide is which one is the rise and which one is the run. As you can see, the rise is that this piece of the treadmill, look at what I'm tracing, there's the y-axis kind of looking, right? That is your change in y. That is your rise. That's your vertical change, and that's why the 10 inches goes on top. And then the length of the treadmill here, you can see that is your run. That's your horizontal length or distance, and that's 48. Now, 10 and 48, rise over run, are both divisible by 2. So divide 10 by 2, divide 48 by 2, and your slope is 4 over 24. Excuse me, 5 over 24. Misspoke, sorry. All right, so here's one for you on page 182. A hiking trail rises 6 feet. For every horizontal change of 10 feet, what is the slope, reduced please, of the hiking trail? So sometimes it helps to make a little sketch. So I made a little sketch here. And what you'll start to notice is we end up with a triangle where we can see our run is one of the legs of the right triangle, and the rise is the other leg of the right triangle, and the hypotenuse is sort of that line that we're trying to calculate the slope of, just to tie those words back to Pythagorean theorem. So once you have the picture, which one is rise and which one is run, you should have put the 6 as the rise over the 100, which is the run. And again, let's reduce this. They're both even, cut them in half. And the slope of this hill would be 3 over 50. Oh, by the way, if you divide 3 by 50, it is 0.06. That's a 6% rise. And that's what these signs are telling people that are driving trucks to kind of watch their brakes as to how steep a slope would be, or a road that they're on. All right, so we're going to take it out of pictures and we're now going to graph. We're going to look at a graph of a line that we've been drawing, and we're going to now determine the slope of different lines off of a coordinate graph. So notice that there are 2 points in the crosshairs. So what I mean by the crosshairs, if I was to stick that point is on the line, but trying to figure out what the coordinates of that point, I need points that are sitting in a vertical horizontal corner. And you're going to see that those 2 are, and that's why those 2 were picked. So you pick 2 points in the crosshairs, and then basically you're going to look and think about if you're coming in from the left. So you're riding up this line, and here's your first point. Imagine that you get into an elevator and you need to get to this point, but you can't go diagonally. So you're going to have to ride the elevator up 1, 2 floors to get to the right level. Now, if the elevator could also go horizontal, much like the elevator if you've read any of the Harry Potter books in the Ministry of Magic, but anyway, if it was able to also run along the floor, then it would go 1 in this direction. So we are going up 2 floors, we're rising 2 floors, and we're running 1. Our slope is 2. This line has a slope of 2. If you write it as 2 over 1, that is the same thing. Okay, so I'm going to ask you to do, on this line, I have put points. And let me let you know that no matter what points you pick on this line, these 2 or the farthest most, any 2 points on the line should give you the same slope. The steepness of the line doesn't change no matter where you're walking up this line. So I'm going to give you a piece of advice, though. The closer the points together, the easier it is to count, the easier the math. So if I was going to do this one, I might pick this point and this point. Oh, by the way, this one or this one. 2 points that are in the crosshairs that are as close together as possible. Okay, what I'd like you to do right now is come up with the slope by finding the rise and the run. Okay, so let's do what I did a second ago on this one. And I'm just going to use this point. And I'm going to get in the elevator. Now, the elevator only goes up or down. So to get to this next point up here, I need to rise 1 block, 2 blocks, 3 blocks. So my rise would be 3. I went up 1, 2, 3, not counting the dots, but the movement. 1, 2, 3. So now I'm sitting sort of in that last dot. Let me just put it back to the way it was. I'm sitting right up here. I went up 1, 2, 3. Now I have to run over 1. So my rise was 3 and my run was 1. And I get a 3 or a 3 over 1 slope. That's how easy slope is when you have a graph. Now, in this time, I'm not rising to go, we're going to still go left to right, just like we read. But notice that this time, the slope of this line is not going climbing, it's falling. So when we go to calculate our rise, we really should use a different word, which would be to fall. And to show that in math, we're going to need to show a negative. So we fall by going down, which would show in negative numbers. So can you calculate the rise, oh, by the way, fall? And can you calculate the run and put the rise over run? And let's see how you do. Okay, so I went from this point down 1, down 2, still not there, down 3, and I'm at the right level. So my rise would be -3. Now I'm sitting right here where my cursor is, and I need to run to the right for that other point. So I would go 1 over 2 over 3 over 4. So my slope would be -3 over 4. And that's how easy it is to calculate slope off of a graph. Okay, well, what about this one? This is kind of a special line and it's horizontal. And my question to you, does this line ever rise? Does it ever go up? And the answer would be no. It has a 0 rise. It does run, but a horizontal line has 0 rise, which would be put a 0 in the rise. And if we counted between any number of points, you could have, between these would be 5. You'd have 0 over 5, or 0 over 4, or 0 over 3. 0 in the numerator over any number other than 0 is a 0. So this, think of it, the floor, which is a horizontal surface, doesn't have a slope. It's a 0 slope. Now, what about this one? Does this line ever run? And the answer is no. This has 0 run. It only rises, right? So your number on top might be 2 or 5, but the number on the bottom would always be 0. And in math, you can't divide by 0. So this line is a weirdo. So any vertical line, the slope is called undefined because you're trying to divide by a 0 run. So undefined slope for our vertical line. So there are 4 types of slope. There is positive, negative, 0, and undefined. Now here's the cool thing. But Mrs. Woodruff, do we always have to graph to find slope? And the answer is no. So what if I'm going to do the graph here just to give you that visual look, but what if I only gave you the coordinates and said find the slope and no graph paper? So let's just find the slope the way we just did and see if we can figure out how to use the numbers here to get the rise and the run. So you see I put these little dots here. So do you see a rise of 2 and a run of 1, 2, 3, 4? This is a 2 over 4. Is everybody okay with 2 over 4? Oh, by the way, that will reduce to 1/2. I want you to get your eyes, though, on the 2 and the 4 right now. Look at the 2. Remember, rise. When you rise, you're going like the y-axis. I want you to look at the y's. Is there anything I can do with the numbers 5 and 3 to get the number 2? Is there any math, adding, multiplying, subtracting, dividing? And do you notice that 5 minus 3 gives you the 2? Remember that run is the x's. It's like the x-axis. So look at the x coordinates. Look at the 6 and the 2. Is there anything I can do to get this 4? Subtract again. So basically, if I simply take the y minus the y, 5 minus 3, I'd get the 2. And if I took the x minus the x, the 6 minus 2, I'd get the 4. So I don't need the graph paper. I could just use my coordinates, y minus y over x minus x. Now, biggest mistake is people want to put the x on top. But remember, rise, y's. You've got to use the y's to rise. And that goes on top, okay? What happens if there's a negative, though? Again, remember, we're going down. We're falling. 1, 2, 3, 4. We went down 4. -4 is our rise. And 1, 2, 3 would be our run. So there is our slope. Now, again, let's take the idea we just did a second ago, and for our y's, look at our y's. So a 1 and a -3, and remember we subtracted them. So I'm going to take -3 minus 1, and I will get a -4. Now for the x's, I'm going to take, for the run rather, I'm going to take the x's, and 5 minus 2 gives me a 3, and I get the same answer. Hey, Mrs. Woodruff, I was going to start with the 1. Okay, well, 1 minus a -3 would be a same change. 1 plus 3 would give you a +4. But 2 minus 5 would give you a -3, and you'd still get a -4/3. So what we're doing right now is using something called the slope formula. Now, when you look at this formula, it looks a lot more complicated than what we were just talking. Really, all it's saying is you're going to have coordinates of 2 points, and you're going to subtract the y's, and you're going to subtract the x's. So these little numbers just mean take the y of the second point minus the y of the first point over the x of the second point over the x of the first point. So the only thing that matters is once you pick which point you're going to start with for the y's, you got to start with that same point for the x's. That's really the only thing that is saying. So here's an example in your book on page 184. They did give you the picture again, but here are your coordinates. I always say put a circle around the y's. Get your eyes on the y's to get the rise. Okay, hear all that rhyming? And now I'm going to make my life easier. I'm going to take the 3 minus the 2 as my choice of y minus y. When I go to do the x's, which aren't circled, I have to start with that -4 on the same, point that I started for the y. So I'm going to take -4 minus the 1. Pick up my calculator to check myself if I need to, but 3 minus 2 is 1, and -4 minus 1 is -5. My slope is a negative. I'm going to drop 1 and run 1, 2, 3, 4, 5. Do you see that? So I'm going down 1 and to the right 5, and I didn't even need the graph paper to get that. All right, so this is your chance to kind of try. I'm going to ask you to do D right now. You're not going to plot the points. You're going to use the formula, and you're going to calculate the slope, and then come back, and then we'll talk about E. All right, so you're going to basically get your eyes on the y's. If it helps to circle them, go ahead and do that. But when I went to subtract, I decided to take 3 minus 2 because that would keep the top at least positive. You could have taken 2 minus 3 and got a -1, okay? But 3 minus 2 is going to give me 1. Now I have to start with the 3's x-coordinate, so it would be 5 minus 2. And 3 minus 2 is 1, over 5 minus 2 is 3, and my slope is 1/3. But Mrs. Woodruff, what if I went the other way? You said 2 minus 3 would give me a -1. You're right. But then you would have had to take 2 minus 5, which is -3. And a negative divided by a negative, a bad thing happening to a bad person, would be a good thing. It really doesn't matter which point you pick to start with, as long as you make sure that when you go to do the x's, these should be the same point, x, y, 5, 3. Okay, your turn. Now with the negatives, guys, listen. You're going to take y minus y. So it's going to be a whole lot of negative minus stuff going here. See, give it a shot and come back. We'll see how you did. I decided to start with the -2 minus the -4. This minus right here is part of the formula, okay? That's the -2. That's the -4, and I have to subtract them. I'm going to same, change it, and -2 plus 4 is 2. Please check yourself as you're doing these in the calculator to make sure you are calculating correctly. Because I started with the -2, I have to start with the -3, and I'm going to take the -3 minus the -7. Whole lot of negative going on. Same, change, and -3 plus 7 is 4. Hey, 2 over 4, they're both even. Cut them in half, and my slope is a positive 1/2. So the last thing we're just going to do today is we're going to say, what if I had one of those tables that we used to do? Remember, like the Fave 5, the Fave 4, and all that? What if somebody gave me a table and they said, hey, these are points that fall on a line, and they asked me what the slope is? Well, you don't have to plot them. And here's the cool thing. These are 4 points on the same line. Pick any two right now. So do you want 1, 12 and 3, 9? Do you want to pick 1, 12 and 7, 3? Pick any 2 points and do what you just did here. Calculate the slope. And it doesn't matter which 2 you pick because it's a line. The slope should be the same. So go ahead, pick 2 points, subtract your y's. That'll be your rise on top. Subtract your x's. That'll be your run on the bottom. And simplify if you can. All right, let's see how you did. Now, you might not have picked my point. I think I went with the first 2. I did. So I'm going to take y minus y. Now, when I go to subtract their x's, I really want to take 3 minus 1, but I can't because I started with the 12. I have to start with his x-coordinate, 1 minus 3, okay? So this is actually going to be a negative sloped line. 12 minus 9 is 3. And 1 minus 3 is negative 2. Now, if you have the negative down here, that's fine, as long as it's in one place. Notice that I did not, and I'm just going to put in equals in there so that's not confusing there. Notice that I did not make it 1.5. We leave our slopes as a rise and a run for now. When we talk about real-world applications, we'll talk about making them what's called a unit rate. But right now, you're just going to leave it that you're going to go down 3, you're going to fall 3, and run 2, and it's okay to leave it that way. So today we started talking about a slope. It is rise over run. In a picture, it's really easy to pick off the rise and the run and simplify. If you're on a graph, you can do block counting. You can count how many squares you go up versus how many squares you go over. Finally, though, you can just be given points and not use the graph by subtracting your y's over subtracting your x's. It doesn't matter which order you go, as long as once you pick the y, you have to pick his x. So notice this is a 0.1, 12. And if you're given a table, don't freak out. Just pick any 2 points and calculate the slope. When you come into class, we're going to do one of each again, at least, and then we'll do some practice. So everything is on a line, and today we're talking about steepness or slope. Guys, have a great day.